is, today what we're going to talk about, other than lag, of course, which is seeming to be a real problem today, is we are going to discuss bond polarity. And the whole reason to discuss bond polarity is eventually we are going to get to talking about molecule polarity. We want to talk about if a molecule is polar, and that becomes really important as we're going to talk about tomorrow, because that affects how molecules interact with one another and interact even with themselves. It really changes how things look to us here in the real world on what we call as chemists the macro scale. But bond polarity is basically you're going to make a bond polar. And when I mention polar, what should jump into your mind is probably polar bears. But if you got a problem with a polar bear, remember you can't run from them. They will run you down. They're scary, scary beasts. But polar, where do polar bears get their name from? But from the fact that they live right in the North Pole. Fun fact for you, right? You ever see those comics where you see a polar bear eating a penguin? Polar bears and penguins live in opposite ends of the world. Polar bears live at the North Pole. Penguins live at the South Pole. They should never interact with one another. But a polar bear would probably eat a penguin because they'll eat anything. They're frightening beasts. But polar, right? Why do we call them polar? Because they live at the North Pole. There is a North Pole. The Earth has a North Pole and a South Pole. And polar basically means that. In chemistry, we talk about polar as having opposite ends of a molecule, right? And so we have, for us, polar has both a positive and negative ends. And ends is going to be something really difficult for us to discuss and really difficult for us to nail down. For a bond, it's really easy to discuss, so that's why it's nice to talk about bond polarity first. So if we want to look at a bond like hydrogen and carbon, we can talk about the polarity in this bond. We can also talk about something like carbon and nitrogen. Those are really easy to compare. Or hydrogen and fluorine, right? So anytime we talk about bond polarity, we just concentrate on the bond between two atoms. We don't worry about any of the extra electrons around either of those atoms, okay? And we're not going to worry about octets, right? We've already dealt with all that mess. We're only going to look at two atoms that are bonded together. To discuss those two, what we're going to do is we're actually going to talk about an old concept. We're going to look at a periodic table you may remember from some old notes. This is the periodic table. I realize the name got chopped off here. This is the periodic table on electronegativity. And if you remember back when we were talking about it, I explained to you that electronegativity is measured by putting two atoms together and you see which one pulls electrons from the other one. Fluorine is the element that's most likely to pull electrons away from something else. And then francium, right, way down here at the bottom, is the least likely to pull electrons away from anybody else. So what we do as chemists is we compare the electronegativities of these elements. We see the closer you are to fluorine, the more likely you are to pull electrons in a bond. So literally, when we look at all these bonds over here, we look and we see which one of these atoms is likely to be pulling electrons away from the other one. So if we look, carbon is slightly higher in electronegativity than hydrogen. So in this bond, we're just going to draw just a tiny arrow above this, just a little tiny arrow that shows that the carbon is drawing electrons away from the hydrogen. And we put a little cross at one end because what that means is since the electrons are being drawn towards carbon, carbon is actually going to get a partial negative charge. That symbol right there means a partial negative. All right. It doesn't get all the electrons, right? If you got all the electrons, then it will get a full negative charge. It doesn't get all of them, so it only gets a partial negative. If you've got a partial negative on one side, you've got a partial, whoops, let me draw this the correct way. There we go. Looks kind of like a note with a tail, a hat at the top. We also can have a partial positive charge over here. Now, the greater the difference between these, the stronger that polarity is right there. There's that right there is the bond. Bod. It is not the bod polarity. It is the bond polarity. There we go. Bond. There we go. Bond polarity. And my chat is blowing up right now. I tell you what, that is killing me. What I'm going to do is just turn my sound down. Bond polarity is what we draw right there. Now, we can put a number on that, okay? So the number that we can put on that, carbon is 2.5, and hydrogen is 2.1. So the bond polarity of this thing is the difference between those two, and that would be 0.4, all right? So that is the polarity of that bond. Now, the higher that number gets, obviously, the more polar the bond is. So let's look at something like carbon and nitrogen. Carbon has 2.5. Nitrogen has a 3.0. So the bond polarity between these two guys is 0.5. Slightly polar bond again. Which one? Where is the arrow going to point? Notice it always points towards the higher number. So we're going to draw this number like this right here. Put a plus on that side, which means that nitrogen is slightly negative and that carbon is slightly positive. All right, let's look at it again. Here's hydrogen and fluorine one more time. You do it. You draw it. You write it. See what you get. Pause the video if you have to. Then we're going to look at it right here. Hydrogen has a 2.1. Fluorine has a 4.0. Holy cow. Look at the difference between those two. It is 1.9. This one is a super polar bond. I'm going to draw a nice dark arrow for that one, showing this bond is highly, highly polar. This one is partially negative. This one is partially positive. So this gives us a lot of information about a bond, right? If I asked you to rank these, if you were to rank these in increasing polarity, right? Which one is the highest, right? Which one is the most polar? Well, it's going to be HF, so that's going to be the highest one. Which one's the lowest one? That would be HC. So we'd say hydrogen-carbon bond is the least polar, followed by a carbon-nitrogen bond, which is then followed by an HF bond, a hydrogen-fluorine bond. So now we can look at how polar bonds are, and we can see what kind of charges that creates. Our next step is going to be to put this into an entire molecule and look how that affects the shape.